All right, let's dive into something pretty massive today. The universe.
Yeah, it's gonna be huge.
It really is. We've got all sorts of research and notes here.
Yeah.
Our goal today is to give everyone listening a sense of the sheer scale of everything out there.
Right. From our own galaxy,
Yes.
the Milky Way, out to the edge of the observable universe and back.
Oh, back. Good point.
Gotta make it back.
We do. So, to start, can you just set the scene? What would it even be like leaving the Milky Way behind?
Okay, so imagine this. As you're traveling outwards, all those familiar constellations that we know,
Right.
they begin to dissolve. Even the sun,
Wow.
our sun,
Yeah.
becomes just another star among billions upon billions of other stars.
It just fades into the background.
Yeah, and then Earth
Yeah.
becomes basically invisible to the naked eye.
Oh, wow. That's crazy.
Yeah, you're just surrounded by this incredible vastness.
It is insane to think about.
Yeah.
That even our galaxy,
Mm-hmm.
which feels so massive to us,
Mm-hmm.
just a tiny little island.
Like a little speck of dust.
Yeah. In this huge cosmic ocean.
Yeah, exactly.
And it's all expanding, right?
Right,
And that's where something called dark energy comes in.
right. Dark energy is this force that we observe. It's accelerating the expansion of the universe.
Pushing everything apart.
Yeah. Imagine an invisible hand just constantly pushing everything further and further away.
So it's not just that things are really far away in terms of distance.
Right.
It's also that they're actively being moved away from us,
Yeah.
even as we're trying to observe them.
Exactly, which makes it even more difficult to see these distant galaxies. They're not just far away, they're also moving away.
It's kind of like we're trying to, I don't know, run on one of those moving walkways at the airport, but it's going in the opposite direction.
Yeah, that's a good analogy. You're constantly fighting against that expansion.
It really puts things into perspective.
Yeah.
When we're looking at these galaxies,
Mm-hmm.
we're not seeing them as they are right now.
Right.
We're seeing them as they were billions of years ago.
Yeah. Yeah, exactly, because the light,
It takes that long to reach us.
it takes billions of years for that light to travel across the vast distances of space.
So it's like we're looking back in time.
Yeah, that's exactly what we're doing.
Every time we look at something in space,
Yeah.
we're seeing its past.
It's a time machine.
That's incredible.
Yeah.
Okay, I'm ready to talk about some specific galaxies.
All right.
So obviously we've got our own,
Yeah.
the Milky Way.
Mm-hmm.
But what else is out there in our galactic neighborhood? Let's start with the Andromeda Galaxy.
Okay.
I know it's pretty impressive.
Yeah, impressive might even be an understatement.
Oh, okay.
Andromeda is a spiral galaxy, just like our Milky Way,
Uh-huh.
but it's significantly larger.
Oh.
It spans about 220,000 light years across
200.
220,000.
That's huge.
Yeah, compared to the Milky Way's roughly 100,000 light years,
Okay, so it's more than double.
more than double the size.
So what does that mean in terms of what's happening inside Andromeda?
Well, for starters, more space for stars. Andromeda has about 1 trillion stars.
A trillion.
1 trillion, while the Milky Way has just a few hundred billion.
Oh, wow.
So there's a lot more going on in Andromeda in terms of star formation and stellar activity.
And it also probably means a more massive black hole at its center.
It does. It suggests a much larger black hole,
Yeah.
which would have a greater gravitational influence on the entire galaxy.
Right, because it's just bigger.
Exactly.
And it's pulling everything in.
Exactly.
And I've heard that Andromeda is on a collision course with our own Milky Way.
It is. Oh, no.
Should we be worried?
Not anytime soon.
Okay.
It's a very slow motion collision.
Okay.
Set to happen billions of years from now.
Okay, good.
But when it does happen,
Yeah.
it'll be quite the spectacle. The two galaxies will merge.
Oh, wow.
Their stars and gas will interact in these complex ways, and eventually it'll form a single larger elliptical galaxy.
Wow, so a totally new galaxy.
Yeah, a brand new
It's
galaxy.
like the combination of two spirals?
Yeah.
Crazy.
Mm-hmm.
Talk about a long-term forecast.
Yeah, we've got some time to prepare.
Yeah, but it's so interesting to think about.
Yeah.
Okay, so Andromeda is big,
Yeah.
full of stars,
Mm-hmm.
and eventually going to become one with our own galaxy.
That's right.
What other interesting neighbors do we have?
Well, let's move on to Messier 82,
Okay.
also known as M82.
M82.
It's what astronomers call a starburst galaxy.
Starburst. That sounds pretty dramatic.
It is.
Intense.
Yeah.
So what's happening there?
So it's a galaxy undergoing a period of really intense star formation.
Okay.
You see, M82 is actually interacting with another nearby galaxy called M81,
Mm-hmm.
and that gravitational interaction between the two is compressing all the gas and dust within M82.
Okay.
And that triggers the birth of new stars at a furious rate.
So it's like a cosmic nursery, just churning out baby stars.
Yeah, like a baby boom.
Yeah.
And because of that intense star formation, M82 is super bright and active, especially in infrared light,
Okay.
which makes it a really interesting target for astronomers to observe.
Okay, cool.
Yeah.
So we've got this. We've got Andromeda.
Mhm.
We've got our own Milky Way. Tell me about Messier 106.
Okay, so M106 is another spiral galaxy,
Hmm.
but it's got this sort of extra flair.
Okay, what do you mean?
So it has a particularly active central region with these jets of gas spewing out from its core.
From the very center of the galaxy.
Yeah, straight from the core.
Oh, wow. So those jets, what causes them?
So at the heart of M106, there's a supermassive black hole.
Of course, another black hole.
Yeah,
They're everywhere.
it seems that way.
Okay, so what's happening?
As matter falls into that black hole,
Yeah.
it heats up, releases tons of energy, and that energy can power these jets.
Like it's shooting them out.
Yeah, it's like a cosmic blowtorch.
That extend far beyond the galaxy.
Exactly.
So these black holes, they're kind of shaping the galaxy from the inside out.
Right.
I'm seeing a theme here.
Yeah,
These galaxies are not static.
right.
They're dynamic
They're constantly evolving.
and changing, and they're being driven by these huge forces at their cores.
Exactly. And as we explore more distant galaxies,
Yeah.
we'll see even more evidence of this dynamic interplay of forces.
Okay, I'm ready to venture further out. Let's leave our little local group of galaxies behind and see what's lurking in the deeper parts of the universe.
Sounds good. We're about to enter a realm where distances are truly mind-boggling, and every point of light represents an entire galaxy,
Oh, wow.
teeming with billions of stars.
Okay, I'm ready.
Let's go. Okay, so now that we've gotten a taste of just how vast galaxies are,
Yeah.
let's focus on a few specific galaxies
Okay,
that really just capture the imagination.
I like that.
We'll be jumping millions, even billions
Yeah.
of light years away.
Okay, I'm ready.
So which galaxy is first on our list?
Well, which one is it?
Let's start with the Pinwheel Galaxy.
Okay, the Pinwheel Galaxy. So is this one of those classic spiral galaxies?
It is.
Like our own Milky Way?
Much like our own.
But what makes it so special?
It has this incredible clarity and structure.
Okay.
It almost looks like a blueprint for how spiral galaxies should look.
Really?
Yeah.
So when we see, those beautiful images of spiral galaxies,
Yeah.
is the Pinwheel Galaxy just a particularly good example of that structure?
Yeah, it really is.
Like what makes its spiral arms so defined?
Well, a couple of factors.
Okay.
Its orientation relative to us is almost face on.
Okay.
So we get this really clear view
Okay.
of its structure. And then also its spiral arms are incredibly bright and well-defined.
Wow.
And that's likely due to a recent wave of star formation that's kind of ignited along those arms.
Oh, wow.
It's almost like they're like cosmic highways where all the gas and dust gets compressed
Right.
and leads to the birth of these new stars.
So they're not just aesthetically pleasing, they're actually like sites of
Yeah.
intense activity.
It's lots of activity.
Yeah.
Creation.
Exactly. That's incredible. So what other visually striking galaxies do we have on our list?
How about the Sombrero Galaxy?
The Sombrero Galaxy. I love this one.
It's got a very distinct shape. It's where it got its name from.
Right. Because it looks like a sombrero.
Yeah, exactly. It looks
Okay.
just like a sombrero.
So what gives it that unique shape?
So Sombrero Galaxy has a very prominent central bulge,
Okay.
which is much larger and brighter than the bulges that we see in other spiral galaxies.
Uh-huh.
And surrounding that bulge is this wide, flat disk of dust and gas,
Okay.
which we see edge on.
Oh, okay.
So it creates that hat-like appearance.
So we're kind of looking at it from the side.
Yeah, we're looking at it from the side.
And that dust and gas is like blocking our view.
Yeah, it obscures a lot of the light
Oh.
from the stars within the galaxy.
So does that make it hard for astronomers to study?
It does present some challenges,
Right.
but it also creates opportunities.
Okay.
We can actually study the dust itself
Right.
to understand, its composition and how it affects the light
Right.
that's passing through it.
Okay.
And using infrared telescopes,
Okay.
we can actually peer through that dust and see the stars and structures that are hidden within.
That's pretty cool.
Yeah, it's pretty neat.
So it's not just a pretty picture.
Right.
It's actually like
Yeah.
a really complex
Yeah.
galaxy.
Like very complex
Yeah.
system with all this hidden depth.
And of course, we can't forget about the supermassive black hole at its center.
Right. It wouldn't be a galaxy without a supermassive black hole, right?
Another black hole. It seems like
Yeah.
these are like a regular,
It seems like they're everywhere.
like almost every galaxy
Oh,
has
we-
one
Yeah.
at the center.
Lurking in the shadows.
Yeah. So I imagine in the Sombrero Galaxy,
Yeah.
it's a pretty active
Yeah, it's thought to be very active.
one,
Yeah.
influencing like the whole
Yeah.
structure of the galaxy.
The entire structure and evolution of the galaxy.
So it's not just like passively hanging out there.
Right.
It's like shaping everything.
It's the conductor of the orchestra.
I like that.
Yeah.
Okay, so we've seen galaxies with majestic spirals,
Yeah.
galaxies shaped like hats.
Mm-hmm.
Do they all have these neat symmetrical shapes?
Not always.
Okay.
The universe is
Yeah.
full of surprises,
Right.
and sometimes those galactic encounters can leave their mark.
Oh, okay.
A good example is NGC 3256.
NGC 3256. Okay, what's special about this one?
This is a prime example of a galaxy that's been through a major collision.
Oh, wow.
Its shape is all distorted and chaotic,
Okay.
with like streamers of stars and gas
Oh, wow.
just extending out from its core.
That's crazy. So galaxies can collide.
They can.
And what happens when that occurs?
It's not like two billiard balls smashing into each other. It's more like this slow motion dance
Okay.
where the galaxy's gravity like pulls on each other,
Yeah.
distorting their shape,
Uh-huh.
triggering like bursts of star formation.
Oh, wow.
And over like millions of years,
Yeah.
they'll eventually merge into a single larger galaxy.
That's incredible. It's amazing to think about these colossal events just like shaping the
Yeah.
universe
Yeah.
over these huge, vast timescales.
Yeah. It's hard to even fathom.
Right. Like
Wait.
billions and billions of years.
Exactly.
Okay, so what other galactic oddities do we
Yeah.
have on our list?
Let's talk about NGC 1275.
Okay.
So this one's visually striking.
Okay.
It's surrounded by these red filaments
Okay.
of gas.
Red filaments. What are those made of?
They're made of hot gas.
Okay.
And how did they get there? They're suspended by magnetic fields
Okay.
that are generated by the supermassive black hole
Oh, of course.
at the center of the galaxy.
Another black hole.
Yeah.
Shaping things.
It's as though, like, the black hole is blowing these giant red bubbles
That's so cool.
into the intergalactic medium.
So they're not just visually stunning.
Right.
We're actually tracing out the influence of that black hole
Exactly.
on its surroundings.
Yeah.
It's like, you can actually see it.
Yeah, I can see the impact
Wait,
of the black
kinda.
hole
Yeah.
on a galactic scale.
And they highlight, I guess, like the way the gravity,
Mm-hmm.
magnetic fields,
Yeah.
and the energy from these black holes
Mm-hmm.
are all playing together.
Yeah, it's all interconnected.
Uh,
It's a complex dance.
Yeah, and black holes are playing a bigger role
They are.
than I ever imagined.
Yeah.
I always just thought of them as these, like,
Yeah.
destructive monsters
Right.
swallowing things up.
Oh.
But they're also driving
Yeah.
these dynamic processes.
They are. That are shaping the galaxies around them.
That's incredible. Okay, we've zoomed in on some
Yeah.
pretty fascinating
Yeah.
individual galaxies,
Mhm.
but I want to zoom out again,
Okay.
like way out.
Right.
You know, I always think about the Hubble Deep Field.
Yeah, that's a good one.
I remember seeing that image like years ago,
It's iconic.
and it just like blew my mind.
It's mind-blowing.
Like, can you remind everyone
Yeah.
what that is and why it's so important?
So the Hubble Deep Field,
Yeah,
it's one of the most significant images
Yeah.
ever captured.
it's by a telescope.
Right, by a telescope, specifically the Hubble Space Telescope.
Yes.
And it's basically a tiny, tiny patch of sky.
Uh-huh.
It looks completely empty
Oh, yeah.
to the naked eye.
Okay.
But when the Hubble Space Telescope
Yeah.
stared at that patch for days,
For days.
for days,
Wow.
it revealed something incredible.
Right. It was just like packed
Yeah.
with galaxies.
Packed with galaxies. Thousands of them.
As far as like,
Yeah. As far as the telescope could see.
right. It's just mind blowing.
Yeah.
How much is out there
Mm-hmm.
that we just like can't see.
With our own eyes.
Yeah.
We need these powerful instruments
Right.
to really reveal the universe to us.
And what's even more remarkable is that some of those galaxies
Right.
are so far away
So incredibly far away.
that their light has been traveling for over 13 billion years
Yeah, it's mind-boggling.
to reach us.
It is.
So we're seeing them as they were
Yeah.
just a few 100 million years after the Big Bang.
Right.
It's like a snapshot
Yeah.
of the early universe.
A baby picture of the universe.
Right, yeah. And it really gives us a glimpse into
Yeah.
a time when galaxies were like forming
Yeah.
and evolving rapidly.
Yeah, just popping into existence.
It was just a period of like
Yeah.
intense activity and change
It was the Wild West of the universe.
that shaped the universe that we see today.
Right. It set the stage for everything that we see around us.
And it highlights just how much is out there
Right.
beyond what we can easily observe.
Yeah, the universe is so much bigger
Yeah.
and more complex.
Than we can even imagine.
Yeah, it stretches our imagination to its limits.
Right. And it's humbling in a way.
It is. It really puts things into perspective.
Yeah, I think that's a good place to
Yeah.
kind of transition.
Yeah.
You know, we've been talking about galaxies billions of light years away,
Mm-hmm.
but I kind of want to come back home now
Okay.
to our own solar system.
All right, back to our neighborhood.
Yeah.
Let's go.
What can you tell us about our cosmic neighborhood?
Welcome back to our own cosmic neighborhood, our
Yeah.
solar system.
It is pretty wild to think
It is.
that while we've been like exploring
Yeah.
the universe,
Vast expanse.
there's a whole other realm of discovery right here.
Right here in our backyard.
It's easy to get like so caught up
Yeah.
in those like huge distances
Yeah.
and forget that there's so much to learn
Right.
about the stuff that's relatively close.
Yeah.
So we've talked about the sun, the planets,
Mm-hmm.
but what about dwarf planets, asteroids, comets?
Right.
Like those are always
Yeah.
a bit of a mystery to me.
They're intriguing objects.
They are. So let's start with dwarf planets.
Okay.
They seem to like occupy this
Yeah.
sort of in-between zone.
Yeah, they're in this weird category
Yeah.
where they're not quite planets,
Right.
but they're not just asteroids either.
Yeah, so what makes something a dwarf planet?
So the key difference is
Yeah.
their orbital dominance,
Okay.
or rather
There-
lack thereof.
Oh, okay.
So a dwarf planet, like a regular planet,
Yeah.
orbits the sun, and it's massive enough for its own gravity
Right.
to pull it into a spherical shape.
Okay, like a ball.
Yeah,
Right, round.
right.
But unlike planets,
Uh-huh.
dwarf planets haven't cleared their orbital paths
Right.
of other objects.
So they haven't quite managed.
They're not like the big...
They're not the bullies of the solar system.
Yeah, they're not pushing everyone else out of the way.
Exactly.
So Pluto's a good example of this.
Yeah, Pluto's the classic example.
It got, like, demoted, right?
Yeah, it got
To
to
dwarf planet.
dwarf planet status
Because it's sharing its space with...
because it hasn't cleared its orbital path in the Kuiper Belt.
Right, which is where it lives.
Exactly.
So Pluto's not alone out there, right?
No, it's got some company.
So what are some other
Yeah.
dwarf planets we should know about?
Well, there's Eris,
Okay.
which is actually more massive than Pluto.
Wow, really?
Yeah, and then there's Haumea,
Okay.
which has a really strange elongated shape
Oh.
because it rotates incredibly fast.
It's like a spinning top.
Yeah, it's almost like a cosmic football.
That's so cool.
Yeah, it's spinning so fast that it's stretched out.
And then there's Ceres, right?
No, yeah, Ceres.
The one in the asteroid belt.
That's right.
Yeah.
Ceres is unique because it's the only dwarf planet
Uh-huh.
in the inner solar system.
Okay, so all the others are way out there.
Yeah, way out in the Kuiper Belt.
Yeah.
And Ceres is hanging out in the asteroid belt.
It's like the
Yeah.
cool kid
Yeah, the lone wolf.
in the asteroid belt.
Yeah, and it's also thought to have a
Yeah.
significant amount of water ice beneath its surface.
Wow, that's pretty cool.
Yeah, it's a very interesting object.
So we've got dwarf planets
Yeah.
in the Kuiper belt,
Uh-huh.
the asteroid belt,
Yeah.
kind of scattered all over the place.
Yeah, they're out there.
So speaking of the asteroid belt,
Yeah.
what exactly are asteroids?
Asteroids are basically leftovers
Okay.
from the formation of the solar system.
So they're like the building blocks.
Yeah, like the scraps.
Yeah, that never quite
Yeah.
made it into planets.
Right. They never got big enough
Right.
to become planets,
Right.
and most of them are made of rock and metal,
Uh,
and they can range in size from tiny pebbles
okay.
to objects hundreds of miles in diameter.
Wow. That's a huge range.
It is. It's a big spread.
Okay, so they all hang out
Yeah,
in this belt between Mars and Jupiter.
right, in the main asteroid belt.
So it sounds like a pretty crowded place.
It is. It's a busy neighborhood.
Yeah. So I imagine there have been some collisions
There have been.
over the years.
Yeah, or over billions of years.
Right. I guess like those collisions could be pretty intense.
They can be quite dramatic.
Yeah.
Yeah, shaping the asteroid belt over time.
So are there any asteroids
Yeah.
that we should be worried about?
There are a few that have orbits
Okay.
that bring them relatively close to Earth,
Okay.
and those are the ones that scientists are keeping a close eye on.
Yeah, we want to make sure they're not coming right for us.
Yeah, we want to track their trajectories and make sure we're safe.
Yeah.
But The vast majority of asteroids are out there minding their own business.
Okay, good to know. So besides potentially causing trouble,
Right.
are asteroids valuable for anything else?
They are actually very valuable
Okay.
scientifically. They're like time capsules
Okay.
from the early solar system.
Okay, so they can tell us about what conditions were like.
Exactly.
Okay.
They preserve material
Yeah.
from that time period.
And so I guess we can study their composition
Exactly.
and learn more about that.
Yeah, we can analyze their composition
Yeah.
and understand the conditions that existed
Yeah.
when the planets were forming.
Very cool.
It's really fascinating.
And are there like useful resources in asteroids?
There are.
Okay.
Some asteroids are thought to contain
Uh-huh.
valuable resources,
Okay.
like water ice
Oh, wow.
and precious metals,
That's cool.
which could be very useful for future space exploration.
Right. You could mine them?
Yeah, potentially.
Yeah.
Asteroid mining is a hot topic these days.
It is pretty cool to think about.
It is.
Okay, so they're not just space rocks.
They're more than just space rocks.
They're like scientific treasures.
Yeah, and potential resources
Right.
for the future.
Yeah. Cool. Okay, let's move on to maybe the showiest members of our solar system supporting cast.
Okay.
The comets.
Comets are definitely captivating objects.
They are. I've always been fascinated by them.
They're beautiful.
Yeah, they're these icy wanderers.
Yeah, they're icy remnants
Yeah.
from the formation of the solar system.
Okay, so they spend most of their time in the deep freeze
Yeah, they're out there.
of the outer solar system.
Yeah, in the cold depths of
Yeah.
the solar system.
Yeah.
Just hanging out
Yeah, but then every once in a while,
every now and then.
their orbits
Yeah,
bring them closer to the sun.
right. And that's when the show begins.
And that's when we get to see
That's when they put on a spectacular display.
those incredible tails.
Yeah, those tails that streak across the sky.
Yeah.
They're beautiful.
What triggers that process?
So it's all about solar radiation.
Okay.
As a comet gets closer to the sun,
Uh-huh.
the increasing heat causes the ice and dust on the comet's surface to sublimate,
Okay.
which means they transition directly from a solid state to a gas.
Okay, so they skip the liquid phase.
Yeah, they go straight from solid to gas.
That's cool.
And that creates this cloud of gas and dust around the comet
Uh-huh.
called a coma.
Okay, so that's the kind of fuzzy.
Yeah, the fuzzy head of the
Okay.
comet.
Okay.
And then the solar wind
Yeah.
and radiation pressure
Mm-hmm.
push this material away from the comet,
Okay.
and that forms the tails.
So the tails are actually pointing away from the sun,
Exactly.
not the direction the comet's traveling.
That's right.
Okay, that's interesting.
Yeah, it's a common misconception.
Right, it's kind of counterintuitive.
Yeah, people often think the tail is trailing behind the comet like a,
Like a streak.
yeah. Yeah, like it's leaving a trail,
But it's not.
it's not. It's actually pointing away from the sun.
And I've also heard
Yeah.
that comets can be pretty colorful.
They can be.
Yeah. So is that because of the
Yeah.
stuff they're made of?
Yes, the composition of the comet can affect its color.
Okay.
Some comets have a lot of carbon-based molecules, which can give them a bluish or greenish hue, and others are rich in silicates,
Mm-hmm.
which can create a more reddish or yellowish color.
That's pretty cool.
It is. It's very beautiful.
It's amazing to think that these objects,
Yeah.
that seem so
Yeah.
ephemeral and delicate.
Yeah, they look so fragile.
Yeah, but they've been around
Yeah.
since the birth of the solar system.
They are ancient relics
Yeah.
from the early solar system.
And they're constantly surprising us.
They are, yeah. We're always learning new things about comets.
We've observed comets releasing like organic molecules,
That's right.
which are the building blocks of life.
Exactly.
So they could hold clues
Yeah. They might hold secrets
to the origins of life.
to the origins of life itself.
That's incredible.
It's really fascinating.
Wow.
And that brings us to a really important point.
Okay, what's that?
Everything we've talked about today,
Hmm.
from distant galaxies
Yeah.
to the planets in our solar system
Yeah.
to these comets and asteroids,
Yeah.
it's all interconnected.
That's true.
The same forces that shape galaxies
Right.
are at play in our solar system.
Yeah, it's all governed by the same laws of physics.
Exactly.
Yeah, the same elements
Mm.
that make up our bodies
Yeah.
were found in stars.
Exactly. We are made of stardust.
Yeah.
It's a pretty poetic thought.
Yeah, it's really humbling and awe-inspiring
It is.
that we're part of this, like,
Yeah.
much bigger
Yeah,
thing.
we're part of this cosmic web.
Yeah, and it makes you want to keep
It does.
exploring,
Yeah.
keep learning.
Keep asking questions.
Yeah,
Keep pushing the boundaries of our knowledge.
Well said.
Yeah.
And on that note,
Yeah.
I think we've reached the end
Yeah.
of our
Our grand tour of the universe.
incredible journey.
Yeah.
We've covered a lot of ground today,
We have.
literally and figuratively.
Yeah. From the edge of the observable universe to the depths of our own solar system.
We really have.
We've seen some amazing things.
Yeah, and explored the vastness
Yeah.
and the beauty
The beauty and the wonder.
of the cosmos.
It's been a privilege to share this journey with you.
Yeah, it's been great having you here.
Thank you.
And I hope that it's inspired
Yeah.
a sense of wonder in all our listeners
I hope so.
and a desire to learn even more.
Absolutely.
So thanks for joining us on this cosmic deep dive.
Yeah, it's been fun.
Until next time, keep looking up,
Yeah.
keep questioning,
Exploring.
and keep exploring.
The universe around us.
Absolutely.
And never stop learning.